All right, we're going to look at some problems in this video from the unit and the types of problems that you definitely want to feel comfortable with for your test. So there's a couple of ways to approach this. You could pause the video when you see the new problem and then try it, and then check your solution with mine, or obviously you can just watch me work through these problems. So a couple of approaching type problems would be converting from degrees to radians and radians to degrees. And what we need to remember for this is that in the unit circle, 2 pi radians is 360 degrees. So that means that we have pi radians for every 180 degrees. So we're going to use that ratio just because it's smaller numbers than the other ratio. So we're either going to use pi over 180 degrees, or we're going to use 180 degrees over pi. And it just depends on which way that we're converting. And instead of memorizing which one to use, I just think about it like I think about the unit that I want canceled out. So in this case, we start with 140 degrees and I want to go to radians. So I want degrees to cancel out. So that means I'm going to multiply by 180 degrees in the denominator, which means pi radians has to go up top, okay? And then I'm just multiplying these two numbers together. So we can think about it like we're multiplying fractions. First of all, I'm going to cancel out the degrees, and then I have 140 pi for the top, and I have 180 on the bottom, 1 times 180. And then my unit is going to be radians. And at this point, I'm just going to go ahead and simplify the fraction. So first, I'm going to divide both of them by 10, so the zeros go away. And then I'm going to divide them both by 2, so 14 divided by 2 is 7, 18 divided by 2 is 9, so I have 7 pi over 9 radians. And that's going to be my answer, or 7/9 pi, however you want to think about that. So again, we wanted the degrees to cancel out, so I put the degrees in the denominator. Now going the other way, if I have negative 9 pi over 2 radians, and by the way, it's radians if it doesn't say degrees. That's just the assumption that we make. So I have negative 9 pi over 2 radians. In this case, I want radians to cancel out. So I'm going to put pi radians in the denominator, and then I'm going to put 180 degrees up top, and I'm going to multiply these two numbers together. Now, first of all, the radians cancel out because we have radians in the numerator and radians in the denominator. And in this case, the pi's are also going to cancel out. So then I have negative 9 times 180, divide that by 2. So we have negative 1,620 divided by 2. And we still have degrees, so it's this many degrees. And then that turns out to be negative 810 degrees. Okay, so I think it's really helpful, like I've said a couple of times already, if you think about what unit you need to cancel out, and then you either multiply by pi over 180 degrees, that's always going to be when you want to convert it from degrees to radians, or 180 degrees divided by pi if you want to convert it from radians to degrees. Okay, now we're just going to look at evaluating a bunch of trig ratios. And when it says find the exact value for each trigonometric expression, it means like we're just using the unit circle to evaluate these particular functions. And we want the exact value, meaning we don't want decimals. We want exact answers. So my approach for these is always to start with just a little coordinate plane to visualize where this angle is going to be. So pi over 6 is really close to the x-axis. This is pi over 6. This helps me because I am able to visualize this triangle right here for pi over 6. And then I'm thinking, okay, the x coordinate is the long one. So that means that that's the square root of 3 over 2. And the y coordinate is the short one. So that's going to be a half. Now, some of you just have these numbers memorized. I like to think about long side, short side, because I know that the longest measurement we have on the unit circle is square root of 3 over 2. And then we have square root of 2 over 2, and then we have a half. So I just say, is it the long the medium, or the short. And the medium, of course, happens when we split the quadrant right down the center, okay? So then I'm thinking to myself, I'm going back to this expression, and I'm thinking, okay, tangent. I don't have those memorized, but I do know that tangent is y over x. We know that tangent is opposite, which is the y side, over the adjacent, which is the x side. So y over x. So I need to take the y coordinate and divide it by the x coordinate. So here's my x, here's my y. I'm going to take the y coordinate of a half, and I'm going to divide that by the square root of 3 over 2. And I know that when I divide fractions, I multiply by the reciprocal, something that we learned way back in elementary school when we were multiplying and dividing fractions. And then I multiply the tops. 1 times 2 is 2. Multiply the bottoms. 2 times root 3. Okay? And then I'm going to simplify. Divide this by 2 and I get 1. Divide this by 2 and I get 1. So I have 1 over the square root of 3. That's what the value is. But we know that we don't leave square roots in the denominator, so we're going to multiply it by 1. So I'm going to multiply by the square root of 3 over the square root of 3. And that leaves me with the square root of 3, because 1 times the square root of 3 is the square root of 3. And then the square root of 3 times the square root of 3 is just 3. So my answer is the square root of 3 divided by 3. That's the exact value. Okay, so the sine of negative 210 degrees. So I know for negative degrees, that just means I'm starting here and then I'm going around this way. So I need to figure out where that's at. The other thing that I know is when I'm looking for the sine value, I'm looking for the y value. The way that I remember that is we have a coordinate pair xy, and it so happens that the x value is the cosine and the y value is the sine. So they both are alphabetical, x, y, CS. That's kind of a nice way to remember that. All right, so negative 210 degrees. If I go all the way here, that's negative 180. So I have to go a little bit further than that. In fact, I have to go 30 degrees further than that. So my angle is happening right here, where this is 30 degrees above the x-axis. Okay. Now this is helpful because maybe you think about it in terms of its reference angle of 30 degrees over here. However you want to do that. For me, I go back to the long side, short side. So again, the long is the x, so that's the square root of 3 over 2. But in this coordinate, the x is negative. And then the shorter side is the y, so that's a half, and it's positive. And if I'm looking for the sine value, I'm looking for the y value, so this is just a half. So all I had to do is figure out where is it at on the unit circle, what are the coordinates, and then sine is the y coordinate, so it's a half. All right, secant. Secant of 7 pi over 3. Now, first thing I do when I see secant is I'm thinking, okay, secant is the reciprocal of cosine. The reciprocal of cosine. So first I'm going to evaluate the cosine of 7 pi over 3, and then I'm just going to take its reciprocal. So as long as you know what matches up, secant matches up with cosine, it's not too difficult of a problem. But on this one, I also have to figure out where 7 pi over 3 is. So there's a couple of ways to do this. One way would be to just count thirds. So here would be 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3. So 7/3 happens at it's the same reference angle as pi over 3. The other way people do it is they take 7 pi divided by 3, and that's 2 1/3 pi, right? So that means we go around the circle once for 2 pi, and then we go another 1/3 pi. So however you want to do that. And then I just need to find the coordinates. So again, my way for doing this is thinking about this triangle. And in this case, the x is the short side, right? So x is a half. The y is the long side. So that's the square root of 3 over 2. In this quadrant 1, they're both positive. So if I'm looking for the cosine, I'm looking for the x. So the cosine of 7 pi over 3 is 1/2. So that means the secant of 7 pi over 3 is the reciprocal of this. 2 over 1, which is just 2. Done. So we make it into an easier problem by saying secant is the reciprocal of cosine. Figure that out, and then take its reciprocal. Okay, let's look at the cosecant of 315 degrees. So cosecant is the reciprocal of sine. So I'm going to first evaluate the sine of 315 degrees. I'm going to figure out where 315 degrees go. This would be 180. This would be 270. So 315 is halfway between the axes right here. So that's going to be a 45-degree triangle. So I know the coordinates here then are the square root of 2 over 2. The x is positive, and then the y is negative, the square root of 2 over 2. So that's my coordinate. So if I'm looking for the sine, that's the y value. So I'm looking at negative square root of 2 over 2. And then that means that the cosecant, the reciprocal, we just flip this. So we have negative 2 over the square root of 2. And then this is the value that I'm looking for. However, we know we can't leave that square root of 2 in the denominator. So I'm going to multiply by 1 in terms of the square root of 2 over the square root of 2. So then I have negative 2 root 2 on the top because I'm just multiplying these two together. And then in the bottom, square root of 2 times the square root of 2 is 2. And then this and this are going to cancel to 1. So then all that I have left in the simplified form is the negative square root of 2. And that's my answer. Cosecant is the reciprocal of sine. So I look at the y value, and then I flip it, and then I rationalize the denominator. Okay, let's look at the next one, the cosine of negative 3 pi over 4. All right, so cosine is the x, so I give myself a reminder of that. I'm looking at a negative angle here, so that simply means I start here and go to the left. So negative 3 pi over 4, 1/4, 2/4, 3/4. Okay, so it's going to be right here. Okay, if it was positive 3 pi fourths, 1/4, 2/4, 3/4, it would be up here. But it's negative, so we went around this way. So then I find those coordinates. I know it's the square root of 2 over 2, the square root of 2 over 2. In this quadrant, they are both negative. And I'm looking for the cosine. So I'm just simply looking for this coordinate, negative the square root of 2 over 2. I don't have to do anything else. I'm done. Okay, so let's look at a couple where we are trying to find a different angle or in a different quadrant that has the same sign. Okay, so sine is the y value. So I'm thinking about that. I'm looking for two angles in different quadrants that will have the same y value. So first of all, I'm looking for pi over 6. And that one happens right here. Okay, so my coordinates for this, I have a positive x and a positive y. I also happen to know that the x is the square root of 3 over 2 and the y is a half. So I am looking for something with the same y value as a half. I didn't even really have to know it was a half because I can visualize, right, that the same y value is going to happen in the second quadrant. It's going to have the negative x, but it's still going to have a positive y. These two angles are going to have the same height, that same y value. So this angle is going to be pi over 6 away from the x-axis, right? This is pi over 6 away. So this is also going to be pi over 6 away from the x value, or x-axis. And we know the x-axis is at pi, so that means that this angle is happening at 5 pi over 6. Because it is pi over 6 away from that x-axis. Okay, you probably just also know that this angle is 5 pi over 6. All right, let's look at another one. Given the angle negative 52 degrees, name an angle in a different quadrant with the same cosine. So I am looking for the same x value, So here's the thing, negative 52 degrees isn't an angle that we just know, or 52 degrees isn't an angle that we just know, but we can use the unit circle to visualize what's going on. So if I'm at negative 52 degrees, that means I'm going this way for negative 52 degrees. So that puts me down here in the fourth quadrant. And in the fourth quadrant, we have positive x's and we have negative y's. So if I want the same cosine, that's the same x value, I have to have a positive x. The only place that that's happening is in the first quadrant. Both of these have negative x. This is negative x positive y. This is negative x negative y. So these quadrants aren't going to work. So it has to be up here. Now if I want the x value, that's how far we're going over to the right. We're going to need an angle like this that has the same x value. It'll just happen to have a positive y. Well, that angle is going to be when we open up to positive 52 degrees. That'll give us the same x value because we will be going over on the x-axis the same amount. Okay? So this one is just positive 52 degrees. And again, we couldn't figure out what those actual cosines were, but we could use that unit circle to visualize that. Okay, that's the last problem. So if you want, obviously you can rewatch this and try some of the problems, or this should help you understand any mistakes you made on the initial test and should help you out with the review.